Okay, so those of you in first bell can thank fifth bell for asking me to make this video. I hadn't intended on doing this, but after talking to them, I thought maybe more people benefit from this than I thought. So let's go ahead and go through it. I'm going to go through all of the review, all the multiple choice, and the free response on this one video. I'll try to get through this quickly. If you don't need help on a problem, just fast forward and go to the next one. Okay. So the first one's asking what's the probability that an airline has fewer than 3 delays. Fewer than 3 would not include 3, so it's actually just 2, 1, or 0. So I need to add those 3 numbers together. When I add those 3 numbers, 0.42, 0.31, and 0.12, that will give me my probability of having fewer than 3 delays. I think the first one was kind of easy, so that's a nice, easy way to get started. The second one, which one of the following is not continuous? Remember, anything that's countable is not continuous. So something like the number of goals scored on a hockey team is countable. The rest of it, distance, time, lifetime, that's all measurements, and measurements are always continuous. Okay, these two both, it's kind of weird, it says refer to 3 through 5, but it's actually just 3 and 4 that use this data. It says, what's the probability that x is less than 7? Again, less than 7 would be only 5 or 6. So when I add those two together, I get 0.25, and that's what number 3 is. When I look at number 4 says, what are the mean and standard deviation of a binomial distribution with n is 20 and p is 0.25? I guess that's not even part of this. I guess only 3 referred to that narrative at the top. Okay, the mean of a binomial is n times p, and this is on your AP formula sheet. The standard deviation of a binomial is the square root of n times p times 1 minus p. In this case, n is 20, p is 0.25. When I do 20 times 0.25, I get that the mean is 5. And when I plug the standard deviation into this formula, which is 20 times 0.25 times 0.75, and I take the square root, I get 1.936. For number 5, it gives us a binomial. It says it's binomial. It says what's the probability that x is 2. Remember, when we're doing x equals a number like 2, this is when we use binomial PDF. PDF is for equals. CDF is for less than or equal to. PDF is for equals. So let's look at how we would do this in our calculator, for those of you that might be forgetting. Okay. We do second, and we hit this distribution button. Binomial PDF. Okay, it's right here. Number of trials, that was n, is 20. P was 0.25. And x is 2. And then we'll paste that in. We'll get our value. So that probability is 0.0669. That appears to be D. Okay. All right. Let's take a look at number 6, not 7. 2 random variables, x and y, are independent. It's so important that they say they're independent, because this is going to be a linear combination problem. So what it's basically asking for is, what's the standard deviation of x plus y? Well, remember, we have to calculate the variance of x plus y first. And the variance of x plus y is just the variance of x plus the variance of y. Well, the variance of x is going to be 6 squared, and the variance of y is 9 squared. And when you do that, that is 100 and, what was that, 162? No, I'm way off there. What am I thinking? It's 36 and 81, which is 117. That sounds a little bit better. Okay, so the standard deviation of x plus y is the square root of 117, which is 10.8. Okay. Number 7. So we'll have a click over. Maybe? Maybe not. Oh, okay, just keep going. Love the technology that we have here. All right, instead of making another video, we're just going to keep going. Which of the following is not a characteristic of a binomial? Okay, it says is not a characteristic. Fixed number of trials is a characteristic of a binomial. The trials continue until a success is observed. This is actually geometric. This is our geometric. So the rest have to be binomial. Trials are independent. Probability of success is the same in all trials. Only two possible outcomes, success or failure. Those are all binomial. So that's the answer is B. Number 8. Well, I can see we're not clicking over again. There we go. 30% of a school district students receive advanced scores in mathematics if you choose 25 students at random. Now notice, it's already telling us there's a fixed number of trials, 25 students at random. What's the probability that more than 10? More than 10. So what I'm really looking for is the probability that x is greater than 10. Okay? This is a binomial because we have a fixed number of trials. The probability of success is the same for each student. The probability of success is 0.3. Okay? N is 25. And then we want x is greater than 10. So remember, 10 goes from 10 on up. Now our calculator only does less than or equal to binomial probabilities. So to put this in my calculator, I have to do 1 minus the probability that x is less than or equal to 10. Now the reason I use 10 here is because 10 is not included here. If 10 was included, I would have to do less than or equal to 9. So if this said greater than or equal to 10, this number would be 9. And then we can just plug this right into our calculator. Now this is where we use binomial CDF. Okay, so I'm going to do 1 minus binomial CDF where I think n was 25, p was 0.3, and x was 10. And this will give me my probability. I get 0.0978 or 0.098, somewhere in that value, 0.0978. Okay, and if I look over here, that is in fact C. All right? But you have to recognize the binomial, and it's again those characteristics that were from number 7. Okay, now they talk about normally distributed values, so I should be thinking z-scores in my head. So normally distributed with a mean of 4.5 minutes and a standard deviation of 0.6 minutes. So anytime I think normal distribution, I should think z-scores. So it says, what's the probability that it will take less than 3.5 minutes for a worker to make a photocopy? That's the probability that z is less than 3.5 minus 4.5 over 0.6. X minus the mean over the standard deviation. Z and x should have the same inequality sign. So z is less than because x is less than. So this is the probability that z is less than, what is negative 1 divided by 0.6? Negative 1 divided by 0.6. So I get negative 1.6 repeating. Okay? So when I go to plug this in, you know, I don't have to get too precise. This is multiple choice. I'm just going to have to get the answer that's the closest. And remember, when we plug this in, it is normal CDF. We're always normal CDF. Since it's less than, my lower boundary is negative bunch of 9s. My upper boundary is negative 1.6 repeating. So I'm just going to fuse 6's in there. That should give me the right answer. And then enter, and I get about 0.048 or 0.0478, something like that. If I look up here, that is letter A. All right, let's take a look at number 10. Maybe. Let's see if this thing wants to cooperate. Sorry for the delay. You might want to fast forward until you see number 10. Oh, come on. Okay, we're back. Number 10. Number 10 I thought was the hardest question on here, just because we haven't seen anything quite like this. It says if there are two independent observations of a random variable. So basically what I'm looking at is I'm looking at y is equal to x plus x. Two independent observations of the random variable. If the random variable has a normal distribution with a mean of 75, so it means the mean of x is 75, and the standard deviation of x is 9. Okay? What's the probability that the sum of these two observations, which is y, is greater than 168? Okay? Well, in order to do this, I need to use my normal distribution, but I have to find out what the mean of y and what the standard deviation of y are. Well, the mean of y is just the mean of x plus the mean of x, or it's 150. And the standard deviation of y has to be calculated by using the variance. So I have to do the variance of x plus the variance of x. So 9 squared plus 9 squared is 81 plus 81. So the variance of y is 162, which makes the standard deviation of y the square root of this. So that's 12 point something, I just don't know what. So let's take the square root of 162. 12.728. Okay? So now we have the standard deviation of y, we have the mean of y. We can calculate the probability that y is greater than 168 by calculating the probability that z is greater than y minus the mean of y over the standard deviation of y. So essentially I need to get whatever 18 over 12.78 is and calculate that z-score. So z is greater than what's 18 divided by 12.728. And I get that is 1.414. And remember, we're doing z is greater than, so when we do our normal distribution, it's normal CDF. Greater than means that 1.414 is my lower boundary, and I'm going up to positive infinity. And I press enter, and I paste, and I go for that, and I get about 0.0787. So it's about 0.0787, somewhere in there. That looks like letter A. Now this was complicated because it made us find the mean and standard deviation of this random variable y, which is the sum of two x's, and then we had to take that mean and standard deviation of y to get a probability calculation for y. But if you notice, it's not much different than calculating a z-score. It's just doing it after we've done that mean and standard deviation. So it basically takes it one more step than what we've done before. Number 11, this is kind of weird because the first one we hadn't talked about. The binomial distribution can be used to approximate a normal distribution, but the sample size has to be big enough. And there is that condition, so it doesn't mean it can always happen. A normal distribution is always defined by specifying mean and standard deviation. And then the standard deviation of the sum of two independent variables is found by taking the square root of the sum of the independent variances, or individual variances. That's true if I had two random variables, x and y, and there's their sum, and I wanted to find the standard deviation of the sum. Think about what that says. I have to take the variance first and say, okay, that's the variance of x plus the variance of y. To find the standard deviation, I have to take the square root of that. So it's the square root of the sum of the individual variances. And that's what I have here. So that actually is a true statement. So it looks like our answer there is D. I'm not too concerned about whether or not you knew number 1, but knowing number 2 and 3 is important. Let's move on to number 12. What's the approximate 93rd percentile value of a normal distribution with a mean of 86 and a standard deviation of 8? So basically what I'm wondering here, 93rd percentile would be somewhere up in here. And this is where 93% of my data would be. Right? And so what I have to figure out is what is this z-score with or at the 93rd percentile. What's the z-score at this 93rd percentile? How can I calculate that? Well, that's what inverse normal is for. Inverse normal gives us a less than probability, a less than, it gives us a z-score for a less than probability. Let me back that up. Inverse normal gives us a z-score based on a less than probability. So our less than probability here is 0.93. If it was greater than, like let's say they gave us 0.07, we would have just done 1 minus to find the less than, and then use inverse normal. Hopefully that made sense. So let me clear this out a little bit. So I go to distribution, inverse normal. Hopefully I can say this again. If I put in the area under the curve being 0.93, because that's what I have here, 0.93, right? What this is going to give me right now is the z-score at that value. So that z-score is about 1.476. So we'll call that z-score 1.476. Well, why is that important? Well, I have the mean and I have the standard deviation. Z is equal to whatever that value is minus the mean over the standard deviation. Now I just need to plug my values in. 1.46 is equal to x minus 86 over 8. I'd multiply 1.46 by 8 and then add to it 86, and I'll get what my x value is. X about 97.68. So that's C, about 98. Okay? So that's what, that should be 1.476. That still would have given me the same value, or a little bit bigger value actually. So this should have been 97.8. So it's even closer to 98, but still you get the idea. Okay? So inverse normal takes us from an area or a probability to a z-score, gives us that z-score, and from that z-score we can do whatever calculation we need to do. 13, height normally distributed, mean standard deviation, approximately what proportion of women heights between this and this. Now I'm going to show you something. I'm going to show you one way that you can do this very quickly in your calculator. You only need to calculate z-scores on your free response questions. So if you want to do this fast and in your calculator, you can use what's given to you. Okay, and here's what I mean by that. If I go to second, distribution, and my normal CDF, if I put my lower boundary in as 65, which is my smallest height, and my upper boundary in as 67.5, okay, and then change the mean to 64.5, and the standard deviation to 2.5, it will actually give me that probability. Now this is great for multiple choice questions. When I switch this back, say I switch this back to when I do a free response question, I want to make sure I change this mean and standard deviation back to a z-score. Now if you don't like that and you want to calculate z-scores the whole way, I completely understand that. But in this instance, this is so much faster that I'm going to do it this way. And I get 0.035, which is about 0.31. So the answer to number 13 is A. And there are a couple of other calculations I could have done that way, but this is a much, much faster way of doing it. 14, 60% of all AP students in a school district complete homework regularly. That's not good. If 8 students from this district are chosen at random, so n equals 8, again it looks like we're getting a fixed number of trials. What's the probability that more than 6? This looks like a binomial. Complete homework regularly. Okay, so p is equal to 0.6, and this is a binomial. So we want to do 1 minus the probability that x is less than or equal to 6. Again, I'm including 6 here because 6 was not included here. Okay? So this is just going to be plugged into my calculator, and I'm going to do 1 minus the binomial. So it's 1 minus the binomial CDF, and the reason it's CDF is we're doing less than or equal to binomial CDF, where n was 8, p was 0.6, and x was 6. Okay? So that probability is not going to be huge, 0.106, so it's about 0.106. That's where we get E. All right, that's number 14. Number 15. Two random variables x and y are independent. It means the standard deviations are shown in the table below. What's the value of the mean and standard deviation? Okay, so we're looking for the mean of 2x plus y and the standard deviation of 2x plus y. Well, this is just 2 times the mean of x plus the mean of y. I wrote x for that first one. It should be y, or vice versa. Okay, so the mean is going to be easy to calculate. It's going to be 2 times 6 plus 8, which is 20. So that was simple. So now I've at least narrowed my guesses down if I'm going to have to guess. Okay, now remember, to calculate the standard deviation, I should calculate the variance first. Okay, the variance of 2x is 2 squared variance of x. 2 squared variance of x. And the variance of y is just the variance of y. Okay? Now the reason that 2 is squared, again, think about it. If I want the standard deviation of 2x, it's just 2 times the standard deviation of x. So the variance of 2x is equal to the square of that. All right, so let's fix this a little bit. But that's where the 2 squared comes from. It's because I'm going to end up squaring both the 2 and the standard deviation of x. So that's where this 2 comes from, or the 2 squared comes from. Okay, so this is 4 times, oh, what's that standard deviation? 0.5 squared plus 0.6 squared. So this is, what, 1.36. And I'm going to have to take the square root of that to get the standard deviation of 2x plus y. So that's the square root of 1.36. Don't know what that is. About 1.166 or 1.17. So that's how we got E. So that's the end of the multiple choice. Hopefully this helps for the multiple choice. I'm going to move from here right into the free response. Some of these are a little challenging, so they might take a little while. All right, first one here, we're talking about preteens and their shopping and the store and what size jeans they have. So the first one says that, first of all, it tells us, you know, that the waist measurement is normally distributed. Normally distributed. I should be thinking z-score automatically when I hear that. The mean, and I'm going to write that down here, mean is 24.4, and the standard deviation is 2.5. And it says, what proportion of female preteens will be unable to find jeans at the store? Well, if you're unable to find jeans, it means your waist has to be less than 20, or means plus, your waist has to be bigger than 28. Now I know that greater than or equal to probably doesn't need to be there, but this says greater than or equal to probably is more precise. Let's just try to be as precise as possible. But we know that greater than or greater than or equal to are going to give us the same value. So I'm going to change these to z-scores. So this is the probability that z is less than 20 minus 24.4 over 2.5 plus the probability that z is greater than or equal to 28 minus 24.4 over 2.5. Okay? So these z-scores that I get are going to have to be calculated. So it's negative 4.4 over 2.5. So this is the probability that z is less than negative 1.76, or the probability that z is bigger than, what's that, 3.6 divided by 2.5, 1.44. Okay? And those I'm going to do in my calculator. So if I bring up my calculator here, so I'm going to do normal CDF for my less than, my value. They've actually got a negative infinity in there already. That's the same as a negative and a bunch of 9s. Mean and standard deviation 0 and 1. Press enter, enter, and I get 0.0392. Round up to 4 decimal places here. If you want to round up to 3, that's fine. Okay? So I'm going to do this again, but now I'm going to do greater than, so I'm going to do normal CDF. This time I'm doing greater than, so my lower boundary is my 1.44, and my upper boundary is a bunch of 9s. And I get 0.0749, 0.0749. And if I add those two numbers together, that should give me the proportion of these preteens that that cannot buy clothes here. So I get that this probability is 0.1141, or approximately 11.41%, and I did that 11.41 as a percentage for you, Young Bin, of these preteens can't buy jeans here. And I guess I should say female preteens, but I've already typed it in, so I don't want to do it again. Or I've already written it in. What proportion of female preteens wear size 2? For part B, what proportion of female preteens wear size 2? Well, that's going to be everybody that has a waist between these two sizes. So that's a probability that 24 is less than or equal to x, which is less than 26. So now I have to make my double z-score here. So this is the probability, and this might get small, 24 minus 24.4 over 2.5 is less than z, which is less than 26 minus 24.4 over 2.5, which is the same as the probability. And now I'm going to calculate that. So I've got negative 0.4 divided by 2.5, which is negative 0.16 is less than z, which is less than, and that's 1.6 divided by 2.5, 0.64. And I'll get that value by using normal CDF again. Actually, when we have two sides to it, normal CDF becomes easier because my lower boundary, the decimal there, 0.16, and my upper boundary are right there for me. Okay, so it looks like about 30.2% or 0.302, or about 30.2% of these female preteens wear size 2. Now, I don't know that I need a summary sentence here. I think the work does it kind of speaks for itself. Part C is probably the most complicated part. We'll move this down a little bit to get to part C. It says if 15 randomly selected female preteens are chosen, what's probably that exactly 5 of them wear size 2? Okay, well, fixed number of trials, certain number of successes, and the probability of success should be the same throughout because there are so many preteens that it's okay to assume that it wouldn't change by picking a few. So N is 15, P is 0.302, that's the proportion of preteens that wear this size 2, and X is 5. So it's a binomial. And that's how I want to write it. So the probability that X is equal to 5 would just be done right in my calculator. Now, if you're a formula person, you'll want to write in that binomial formula. 15 choose 5 times 0.302 to the 5th power times 0.698 to the 10th power. But you don't have to do that formula because the calculator does the formula for you. And we use binomial PDF because it's a single value. If it was a less than or equal to value, we'd use CDF. So our number of trials is 15. Our probability of success is 0.302. And our number of successes is 5. Paste that in. I get a probability of 0.0207. I think it was 0.207. I think I said 02, but I believe it was 0.207. 207. All right. Okay, so that's the first free response question. I think the really difficult part there was part C, recognizing that this turned into a binomial. But anytime you see, hey, we're choosing a certain number, and we're looking for a certain number of successes, fixed number of trials, certain number of successes, boy, we really should be thinking binomial. Now, where did that probability come from? Well, size 2 came from the previous problem. Okay? All right, last one. This is going to use our binomial random variables. It's going to do a couple of different linear combinations. Okay? So part C, I think, is really complicated here. Part A and B, I think we should be able to get pretty reasonably. So let's start with part A. It says, Kylie wants to know how likely it is that she will have to wait more than 4 minutes at a major intersection by her house. And it helps that it says that these are approximately normal. Okay? And it gives us the mean and standard deviations. So at the major intersection, here's the mean, and here's the standard deviation. So the probability that x is greater than 4, more than 4 minutes, is the probability that z is greater than x minus the mean over the standard deviation. Okay? So this is equal to, what's that, 0.8 over point, so that's 1.6. Probability that z is greater than 1.6. Okay? And then we'll put that in our calculator. Once you show the z-score, you're showing, hey, I know it's a normal distribution. I've given the correct boundaries. I know what I'm doing. Greater than, so 1.6 is my lower bound. My upper bound's a bunch of 9s. Paste, calculate, and there's our value. So let's call that, we'll call that 0.05. Let's just call it 0.055. Technically, you only need to round off to 3 decimal places. Okay. Now it says Ella must travel through 2 major intersections and then 3 secondary intersections. So 2 major intersections, 2 major, and 3 secondary. That's part B. I'm going to say M is the wait time at a major intersection and S is the wait time at the secondary intersection. Kind of fit that in there. I'm just going to say this is equal to some variable. I'm going to call this y. It's just easier if you make it a simple variable. It says we're assuming they're independent. What are the mean and standard deviation of their total wait time? So basically what I'm looking for is what's the mean of y? Well, that's just going to be 2 times the mean of m. I should make that a better m, or I might get trouble thinking it's a mu. 2 times the mean of m plus 3 times the mean of s. So this is 2 times 3.2 plus 3 times 2.5. 2 times 3.2 plus 3 times 2.5 is 13.9. So that mean wait time there is 13.9. That's the mean wait time, so that's mu sub y. Okay, and now we have to find the standard deviation of the total wait time. Okay, so now we need to find sigma sub y, and we do that by finding the variance. So it's going to be 2 squared sigma sub m squared plus 3 squared sigma sub s squared. So this is equal to, what are the mean and standard deviations again? So this is 4 times 0.5 squared plus 9 times 0.7 squared. Okay? So 4 times 0.5 squared is just 1. So it's 1 plus 9 times 0.49. So it's about 5.41. So that means the standard deviation of y, standard deviation of the wait time, is the square root of that, the square root of 5.41. So the square root of that is about 2.326. That's the mean of y, and that's the standard deviation of y. Okay? Oh man, I did that all wrong. Son of a booger. Alright, now looking at this, and I look back up, and I see this word here, independent, and I realize that I just did this part all wrong. The mean is going to be calculated the same way, but I did not put into account that it said independent. I don't know why I did that. I don't know how I drew a blank, but I just did all of this basically wrong. And hopefully those of you watching this understand why this is wrong. In fact, this should probably be written differently as well. It should be not written as 2m plus 3s. It should be written as y is equal to m plus s plus s plus s. Now the mean of y is still going to be calculated doing 2 times 3.2 plus 3 times, what was it, 2.5, okay, which is 13.9. But the standard deviation I threw way off, so that was terrible, but make mistakes. So the variance of y, let's try this again, is going to be the variance of m plus the variance of m plus the variance of s plus the variance of s plus the variance of s. I apologize for the mistake. Glad I caught it before I finish this. So let's put this in. This is 0.5 squared plus 0.5 squared plus 0.7 squared plus 0.7 squared plus 0.7 squared, which is about 1.97, which gives a hugely different standard deviation. It's the square root of 1.97, which is 1.4036. All right, that was terribly long, or terribly wrong. But good thing we got it right, because the next thing is, what's the probability that the total wait time will be less than 12 minutes? So actually what part C is asking for is, what's the probability that y will be less than 12? Well, we already have the mean of y, and we have the standard deviation of y, so that we can do just by simply using a z-score. So it's probability that z is less than 12 minus 13.9 divided by this 1.4036. Okay? So that's the probability that z is less than negative 1.3537, which is about 0.0879. Or if you put 0.088, I'm fine with that. Apologize for the mistake. At least I got it corrected. Hopefully this video helps. If you have any extra questions, like I said, I will be in early Thursday morning.